All right, another example here, and I'm just trying to give you a variety of, there's so many different kinds of identities we can work with. So I'm trying to give you a little bit of a variety, some of the different strategies we might use. So here's one. We've got secant 5x minus 1 times secant 5x plus 1 equals tangent squared 5x. Well, to me, the left side definitely got a little more going on than this side. Tangent squared 5x, that's pretty simple. So let's use our algebra skills. Let's combine. So we're actually going to multiply out this left side and see what happens. So let's go ahead and do that. Now, if I multiply this out here, let me get my pen ready. So secant 5x times secant 5x. So of course that is secant squared of 5x. Now I get minus secant 5x plus secant 5x. So that's going to cancel. And then I get minus 1, negative 1 times 1. I guess I didn't write this out like I did in the previous two examples. So again, I'm working with this side. So we just multiplied that out. Well, this might not look very simple. Secant squared 5x minus 1. Again, though, if I see one of these things squared, I want to go look at my Pythagorean identities. Okay, so I automatically go look at your Pythagorean identities. And if you turn that, you've got your trig sheet there close, I hope. I'm looking at mine. If I find my Pythagorean identities, they're on your fundamental identities on your sheet, and I look at secant squared, well, secant squared is the same as tangent squared plus 1. So let me go ahead and substitute. So secant squared right here, that's the same as tangent squared of theta. Now, 5x is my angle, so I'm just putting 5x plus 1. So this right here, tangent squared 5x plus 1 is the equivalent of secant squared 5x. That's a Pythagorean identity. Then of course I've got minus 1. Well, pretty clear what happens here. 1 minus 1 goes away, and so we've got tangent squared 5x. Again, pretty quick on that one.